Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. We spent the last couple of episodes writing an FBX importer and used it to import various 3D models into the editor. However, the code that navigates the FBX scene looking for meshes isn't quite working correctly, and I'd like to fix that in this video. Let me illustrate the problem that we are having by showing you some combinations of how nodes in an FBX scene can be related to one another. The simplest scene tree is one that has got separate nodes in it. Like we see here, we have 3 nodes, one for each object. We can move each object independently, and if we were to import this scene, we would end up with 3 asset files. Another possibility is that objects are somehow grouped in a kind of subtree. Here we have a group node, but it could as well have been a light node or a camera node or even another mesh node, and the 3 objects here are now parented to this group node. So if we would move this group node, all objects within it would move with it. Of course, we are still able to move each object individually, but their transforms are relative to the group node. Next example is one that we have already seen in the previous episodes, which is an object with multiple levels of detail. This is simply represented by an LOD group which has a number of mesh nodes as its children. This pretty much behaves as a group node, except that child nodes are shown depending on camera's position. We can also parent a mesh node to another mesh node, as we see here. However, we are not limited to any particular combination. For example, a mesh node can have an LOD group as one of its child nodes. We can also go bananas and parent a group node to a mesh node, along with another mesh node hierarchy and an LOD group. We can even have an LOD group within another LOD group, which doesn't make much sense in practice, but we can totally create such a hierarchy and save it to an FBX file. So how do we make sense of all these possibilities while we don't support such combinations in our geometry format? Remember, the submeshes in Primal Engine don't form any kind of hierarchy, except for objects with multiple LODs, which simply have a group of submeshes for each level of detail. Let me explain the strategy which I plan to use for this. As an example, suppose we have a mesh node, a group node with a couple of mesh nodes attached, and finally, an LOD group with also some mesh nodes for each level of detail. In this case, we would save the LOD group to a separate asset file, the meshes within the group node would be saved to another asset file, and finally, the single mesh would be saved to yet another asset file. So we would get 3 asset files for this scene. But what if we had a more complicated scene hierarchy? Maybe we have a mesh tree with different meshes and even a group node in there. In this case, I'll simply make a flat list of all meshes within this tree and save it to a single asset file. If there was an LOD group somewhere, we always save it in its own asset file. So in the example that we have here, the 3 meshes would be saved to one asset file and the LOD group and its meshes would be saved to another file. I believe this accounts for most of hierarchies that we could encounter while importing an FBX file. Obviously, this is nothing but a design choice that I made here. Some game engines would actually use the FBX hierarchy to relate the game objects. For example, a car and its 4 wheels could be constructed as a mesh node for the car with 4 child mesh nodes for the wheels. In our engine, we'll either save each mesh in an asset file and relate them using game entities, or import all meshes as one object and use skeletal animation for spinning the wheels. To summarize, meshes on the same node tree will be saved in one asset file. Meshes in a group node will be saved in one asset file as well, that is if the group node is the root, otherwise it will be saved as a part of the mesh tree. So if a group node is parented to another mesh or group node, it will be part of the same asset. LOD groups are always saved in a separate asset file, regardless of whether they are parented or not. And finally, we will split meshes into submeshes by material, which brings us back to the model we have here. This version has all submeshes combined in a single mesh node that uses different materials. When we would separate these meshes in Maya, it will become rather difficult to work with since it splits into a large number of mesh nodes. I did this because the current implementation of our importer doesn't work with group nodes. However, I made another version of the same model which consists of only 5 mesh nodes grouped together, and according to the rules that I just discussed, it would be saved into a single asset file. Going back to our code, I'll start with the getScene function. First, I remove the part with LOD group and recursive call to getScene. We'll deal with LODs later. We also don't check for mesh nodes here. All we do now is iterate through all child nodes and get all meshes in each child node's hierarchy. That's why I'm renaming getMesh function to getMeshes and also change its parameters. Like before, we start with an FBX node and we use a vector where we put all meshes that we encounter. In addition, we need an ID to group submeshes within an LOD. We also need to pass the LOD threshold, which is -1 if we don't have an LOD group, or we are just getting the first level of detail of an LOD group. To get the mesh itself, we examine the node attributes instead of the node. So I change getMesh function's parameters accordingly. For LOD groups, we also look at node attributes, but in that case we don't need the extra parameters as we'll see in a minute. In getMeshes function, we need a boolean variable that indicates whether or not we are getting meshes that are part of an LOD group. If the node has any attributes, we'll examine them next. For each node attribute, if it's a mesh attribute, then we call getMesh function, and if it's an LOD group attribute, we call getLOD group. We also set isLOD to true. I'm assuming that a node either has one mesh attribute or one LOD group attribute, otherwise this boolean wouldn't have the intended effect. A node can have other types of attributes besides mesh or LOD group attributes. Most nodes typically have a transform attribute, for example. After we examine all node attributes, if this node was not an LOD group, we'll drill further down the hierarchy to see if there are more meshes we can get. Therefore, for each child of the current node, we recursively call getMeshes with the same list of meshes, LOD ID and LOD threshold. Now we need to rewrite getMesh function to use a mesh attribute. We can simply cast the attribute to an FBX mesh pointer, and the rest of the function is pretty much the same. We do need to get a pointer to the node that has this attribute in order to get this mesh's name. Also, we'll use the LOD ID and LOD threshold that are given as function parameters. That's it for getMesh function. Let's move on to getLODGroup function. Again, it will use an attribute instead of a node, and we cast the attribute to an LOD group pointer. We also get the node that owns this attribute, like we did in getMesh function. The way we get meshes within an LOD group is now simpler. We look at each child node, get its LOD threshold value, and call getMeshes on that node to get everything that's part of that branch. Note that for each node we use a different LOD ID, which should make sense because each child node is the root of one level of detail. When we call getMeshes for the first time in getScene function, we use 0 for LOD ID and -1 for LOD threshold parameters. This should be enough to import meshes and group them in asset files according to the rules which I explained earlier. Let me first delete these separate files before testing. I just dropped the character model with submeshes grouped together, and if we did everything correctly, we should see one file being added here. And here it is again. We can also import the file with LODs, and it works too. I'm going to create a scene that consists of a group node, an LOD group, and a couple of mesh nodes. First, I'll add an LOD group and also define some materials so we can see the objects more easily. Next, I add our character model, which is quite a bit larger, so let's scale everything to match. The default length unit in Maya is centimeters, so we need to scale things up if we are measuring in meters. I'm just playing with LOD thresholds a little bit here. And then I just duplicate this LOD group and parent it to one of the meshes from the character model. If our scene traversal code works as intended, we'll get 3 asset files when we import this file. Let me remove the files that we already have and drop the new FBX onto the editor to import it. As you can see, we get 2 files, but that's because 2 of the files that were saved had the same name. So we need to fix that where we determine asset file names. Everything else seems to be working correctly, although the LODs appear to switch a bit odd. To explain why that is, I'll create a group of objects, all of which have their own positions relative to the group. When we import this scene, we see that everything is centered around the origin. You can't see the cube because it's smaller than the sphere around it. I can try to make it larger or stretch it. However, as you can see, that didn't change the resulting mesh. The reason for this is that each node in the FBX scene has a transform matrix that we need to apply to each vertex when we import each mesh node. In addition to node transform matrices, each attribute may also have a transform relative to the node, which is called a geometric transform. Some game engines might create a game object straight from the imported mesh and set its transform component according to the transform matrix from the FBX file. However, since we are not creating game entities when we import meshes, we need to bake transform matrices into mesh vertices. This is done by multiplying all transform matrices by each vertex's position. In the importer code, when we get mesh data, we can also get the geometric transform for that node. We also evaluate the global transform from the node and multiply the two matrices to get the final transform. You can read more about transforms in the FBX documentation. I'll add a link in the video description. As I mentioned, we need to transform each vertex position using this matrix by multiplying them together. I'll also multiply the normal and tangent vectors to transform them. In case of tangent vectors, we need to back up the fourth component because it contains the handedness of the tangent vector. So we only transform the x, y, and z components and write back the handedness. Looking at the imported geometry, we now see that the shapes are at positions that we would expect, but something is quite off with the shading. To explain what's happening, look at what happens when I transform this drawing. The green line represents a surface and the yellow line is the surface normal vector. Applying the same transform to both of them doesn't preserve the perpendicular property of the normal with respect to its surface. We can mathematically derive what we need to do to keep the normal vector perpendicular. I'm not going into details here, so feel free to pause the video and look up more about vector transformations. It turns out that we need to transform normal vectors using the inverse transpose of the transform matrix in order to keep it normal to the surface. In this example, after scaling the surface in the x direction, we need to apply the scaling to the normal vector in the y direction. Also remember that this transformation doesn't necessarily result in a unit vector, so we need to normalize the normal vectors afterwards. Fortunately, we can simply call functions from the FBX SDK to calculate the inverse and then the transpose of the transform matrix. This is an example of why I try not to use libraries. Although it's really easy to call these functions to get what I'm looking for, if I had no idea how to invert a matrix, I still wouldn't have learned anything new. Anyway, now that we have the inverse transpose of the transform matrix, we can use it to transform the normal vectors. I probably shouldn't have transformed the tangent this way, since tangent vectors are parallel to the surface, but that gives us something to compare when we are rendering our scene using textures. Re-importing the FBX file, we immediately see a huge improvement. One more thing to notice is the fact that the number of vertices and indices is equal, which shouldn't be the case. In general, we should have more indices than vertices, because we unify identical vertices. This character model, which was imported before we wrote the transformation code, has less vertices than indices. I'll rename it and import it again, and it has indeed no unique vertices anymore. Remember I mentioned that transforming normals wouldn't preserve each vector's unit length? Looking at how we unify vertices, we see that here we are assuming that normals have unit length, and when that's not the case, it would fail unifying vertices. We could renormalize each normal here again, but I rather do it after the transformation in the FBX importer. Visual Studio is a bit confused here, so I'll restart it. And then we can normalize normal vectors as well as tangent vectors. Re-importing the character model, we see that the number of vertices is again correctly reduced as it was before. I think this is good enough to deal with most FBX models that we get to import. I would recommend to search the internet and download as many different FBX models as you can find and test if the importer can handle them. And this is where I'd like to leave it for today. I hope you had a good time watching this video. Thank you so much for joining me, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!